All right, I would like to go through with you the 3 types of word problems that we talk about for addition and subtraction in our classroom. All right, so these are the notes that your students probably have. There are 3 kinds of addition and subtraction word problems. There are combining problems. Combining means putting together. Combining problems are always addition. Comparing problems. Comparing means telling what or who has more or less. Comparing problems can be solved with either addition or subtraction. And the third one is take away or take apart problems. Take away problems have things that get sold, lost, given away, eaten, or separated. That's just an example. Take away or take apart problems are always subtraction problems. And we're going to see that in action in these 3 examples. All right, CJ had 84 Skittles. He gave Micah 21 Skittles for being such a great partner. How many Skittles does CJ have left? I would challenge students to figure out first if we're combining, comparing, or taking away or taking apart. Is CJ getting more Skittles? No, it says he gave Micah Skittles, so he's not combining. Are they comparing how many Skittles each child has? No. Are we taking away or taking apart? Yes, he has given away some Skittles, so this is going to be a subtraction equation. Once we know that, and we do practice writing that this is take away, which is subtraction. CJ had 84 Skittles. He gave, subtraction, Micah 21 Skittles. How many does he have left? So our equation is 84 minus 21. And once we're down to this is naked math, and we can solve this. We've got all the words out of the way. I have given 3 examples of, of ways that we can solve this. We can use tally marks. I don't really have any interest in drawing 84 tally marks. We can use a number line, which is my favorite, but the students are not quite here yet, all of them, or base 10 blocks. So I'm going to model both of these really quickly for you. When we do subtraction, we model only our first number, what we're starting with. 30, 40, 50, 60, 70, 80, 84. And then I can subtract the 21 Skittles that CJ gave to Micah. There's 1, that makes 11, that makes 21. And I can see that we have 10, 20, 30, 40, 50, 60, 3, 6 tens, 3 1 Skittles left. I'm going to solve this with a number line really quickly. This is an open number line. When we subtract, we start on the right because we're going to be going backwards towards 0, or towards the lower side. So 84, we're going to subtract 2 tens and 1 1. I know 84 minus 10, if we go backwards 1 10, is going to take us to 74. If we go backwards 1 more 10, 7 tens minus 1 10 is 6 tens, 64. So there's our 2 tens. And then we're just going to do tally marks. So we only have 1. Minus 1 more. 64 minus 1 is 63. So this is a really good strategy that can work for numbers of any magnitude, which is why I favor that over anything else. But it does require understanding those tens and ones and the way we can subtract and add them a little more fluently than some of our students are now. All right, and lastly, we have our difference. We're going to put it back into our equation and we're going to check our work. So we know that the fact family addition sentence of this would be 63 plus, so we have the 63 Skittles that CJ has left. If we give him back the 21 that he gave Micah, we should equal 84. So 63, 21 should equal 84. And I see that I have 4 1s, 6, 7, 8 10s. So that agrees. I will not do the number line this time. So that is an example of a takeaway problem. Okay. Our next story says Riley built a tower of 94 Legos. Cameron's tower had 52 Legos. how many more Legos would Cameron need to use to match Riley's tower? And looking at our examples, it does sound a little bit like combining because we are doing Legos, which is a building thing, but this is a comparing. We're seeing somebody has more, someone has less, and we're going to solve the problem that way. Comparing can be solved with addition or subtraction, and I'm going to show you why that is. Okay, Riley has 94 Legos in her tower. Cameron's got 52. We need to know how many more Cameron needs to add to make Riley's tower. So our equation is 52 plus something equals 94 Legos. Now, we can see that this is an addition equation, but we don't like to solve equations that have question marks in the middle. No way. So we're going to fill in our fact family. 52 plus question mark equals 94. And if you are not familiar with this colorful fact family, please check out the video that goes into great detail on that.
Is there any more paper?
All right, so here are our 4 equations. This equation right here puts the unknown number by itself. So this is going to be our equation that we like to use. So you'll see that it's a subtraction equation. 94 minus 52 equals question mark. 94 minus 52 equals something. So if we take the number of Legos in Riley's tower and subtract what Cameron already has, we're going to find out how many he needs to equal the same that she has. So I'm going to model the 2 ways. There's 9 tens, 4 ones. I'm going to subtract 2 ones and 1, 2, 3, 4, 5 tens. And you'll see that we're left with 4 tens, 2 ones. Quickly with the number line, we're going to start on the right side because when we subtract, we start on the right side. And we're going to go backwards 10, and we're going to do it 5 times. 1, 2, we might have to make these a little smaller. 3, 4, 5. Okay, let's see. 94 minus 10 is 84. Down another 10 is 74, 64, 54, 44. Minus 2 ones. Yes, you may. 44 minus 1 is 43. And 42. That one needed a longer number line. All right, and we're going to check our work by putting, first of all, let me circle my answer. 42 Legos. So I'm going to plug 42 into our first equation to make sure that it adds up to be 94. Make sure we have the right answer. And I'm going to use the number line this time to check my work. So when we add, we start at the left end, and we can choose either one of our numbers to start with for addition, and I always start with the greater number because then we have fewer steps to go. 52. And we're going to add 10 4 times because our new add-in has 4 tens. 1, 2, 3, 4. So 62, 72, 82, and 92. If we go up in the tens place, just go up 1 every time. And then we're going to add 2 ones plus 1. It's 93. Plus 1 more is 94. So we got to 94, which is what we have in our original equation, which tells me that 42 is the correct answer. I'll do another video to just do this number line process in a slower, more explained way. because I really think it's a really good strategy. Anyone can draw this number line, and it's easier to keep it neat and organized compared to the base 10 blocks. It is less concrete than the base 10 blocks, so sometimes it just takes a little while for us to be ready to get there. All right, let's do one more. Jayshawn brought 43 marshmallows to share with his friends. He found 55 more marshmallows in his backpack. How many marshmallows does Jayshawn have now in all? So this is a combining problem because Jayshawn had some marshmallows and he found some more marshmallows and we're putting them all together. Combining problems are always addition. So I'm going to write that we are combining, and that is addition. So he had 43 marshmallows. We found 55 more marshmallows. More often means plus. If you want, you can wait a few minutes. Sorry, it's time for kids to get here. All right, our equation is 43 plus 55 is going to equal the number of marshmallows that Jayshawn has in all. We're going to always try to have our units written down. I don't think I did that in the first example. That's going to be really great practice for when we get into math and science that has different units that were all mixed together. So 43 plus 55, 4 tens, 3 ones, 5 tens, 5 ones. I've got 8 ones and I have 9 in the tens place. 98 marshmallows. I'll try the other strategy in addition just to double check. Good morning, sweetheart. Okay, and when we add, we're going to start on the left because we're moving up to a greater number. 55, and we're going to add 4 tens. 1. Students are starting to arrive, so you might hear some extra sounds. Okay, 5 tens. We're going to go up to 6 tens, 7 tens. Oops. 8 tens and 9 tens, and then 3 ones. 1, 2, 3. 96, 97, 98. So we got the same sum either way. Of course, the students do not need to work these out in different ways. They can choose the way that works best for them and that they're most successful. All right, it equals 98. And we are not going to do subtraction to solve because we're more likely to be accurate with our addition. So we're not going to check our work with subtraction. That's where our mistakes usually come up. So these are the 3 word problem types that we've discussed. I hope this helps, and if you have any questions, of course, do not hesitate to give me a call, and I'll be happy to clarify any misunderstandings. Thanks for watching, as always.